sweetie. This way. Oh. Go on. Go on. I'm coming with it on. Go ahead.
All right, guys. You guys can hear me all right? Okay. So before we start, you guys can either hop in the chat or you can just turn your mics on. But what did you guys think of the first 3 videos kind of together of those AP videos? Do you guys want to continue to do those again this week or not as much? Kind of make it optional. Okay, we do know that if I do say optional, that means we're gonna have different homework from me, right? But you think that would still be better? Okay. So what I'll do is they kind of post probably like 2-ish days in advance what the lessons are going to be. So for example, today's lesson for them is like reasoning with slope fields. So it's probably it's definitely more one that I would say is like much more optional because usually it's a multiple choice question. But tomorrow's is finding particular solutions to differential equations. So that's the whole like that's the whole dy dx equals like xy squared, which is very important on the free response. Like I said, it was six questions, 6 points. I mean, 6 points whenever that pops up. So that's one where if you need a refresher on it, I would definitely watch tomorrow's, but we can kind of make them optional. I like Carlos's idea where it's, if it's something that you feel like you need a refresher on, 2 times speed is probably a good refresher. Okay, so then for today, what we will do is originally I was gonna have, so I have 4 questions here. They're all calculator questions. So I'm gonna pull up the Inspire actually in here. There we go. So we have 4 calculator questions. I'm gonna skip one of them and make it extra credit if you guys want to do it on your own. I'll give you, if you turn it in, I'll give you a 6 out of 5. The reason it's going to be extra credit is it's area and volume, which the AP did remove from our test. So we'll solve the other 3 together. And then you guys who are here will have no homework. But if you want to do that fourth one will become extra credit. So let's read through this first question. This first question was from the 2014 exam. And so it says, it gives us a table. So as soon as we see the table, usually whenever we see the table, we're kind of thinking that we're going to have a Riemann sum somewhere is a good guess. So we see the table and it says Ruth rode her bicycle on a straight trail. and she recorded her velocity v of t in miles per hour. So it's something to be, kind of underline, highlight for selected values over t. They did not say anything about continuous. They did not say anything about increasing. So we're not going to have any of those IVTs, overestimates, underestimates, but those are words to look out for as well. A says use the data in the table to approximate Ruth's acceleration at 1.4. So if we want to get to acceleration, which is, right, we're thinking position, velocity, acceleration. When we go down, we're doing the derivative. And when we go up, we're doing the integral. What you'd kind of also add on to this is for approximating, going down is y2 minus y1 over x2 minus x1. And going up would be Riemann sums. So we're at velocity. Going down to acceleration would be y2 minus y1 over x2 minus x1. So for A of 1.4 is going to be approximately, and then between 1.2 and 1.6, so 16.3 minus 17.2 over 1.6 minus 1.2. And you could leave your answer like this, but because we're using units and because we have a calculator, I'd recommend just typing it in. We get negative 2.25 miles per hour squared. And regarding units, just remember we took a derivative. So whenever we take a derivative, we add on a per time. Now, it said using correct indicate units of measure. So we do want to go back and just make sure that we looked at everything. Show the computations that lead to your answer. What that means is they're asking us to make sure that we showed this line here. We don't need to show any work. We have a calculator, but we need to write what we typed into the calculator. And then indicate units. We have them. So that's worth 2 points there, 2 out of 2. Okay, B says using correct units, interpret the meaning of the integral from 0 to 2.4. This is one a lot of us had issues with during class. And a lot of it was because we didn't use our correct units. My kind of standard on this, if you wanted to kind of like have, say, a sentence starter to memorize, is to first put the integral. So always put the integral. And then you can put just is an easier word. Some people put indicates or represents, but is fine. So is. Now we want to think, what is V of t? V of t is always just the change in position. Now they did say here that the velocity is always greater than 0. Whenever that's the case, technically, in your answer key, you'll see is the total distance, because if you can't ever go backwards, right? Like if this was your starting point and you're always moving forwards and you can't ever go backwards, then essentially distance becomes the same thing as change in position because you can't go backwards. So that's for V is greater than 0. If we had going forwards, then coming backwards, then going forwards again, right? This is where in this middle part, V was less than 0. Now our distance is not equal to our position. because our position would be right here. But for our distance, we would have actually added that amount going backwards and forwards. So we would have added that little amount twice because once was going backwards and once was going forwards. So our distance would be way out here. So that's just something to note. Now, I think I told you guys I wouldn't really worry about that on the AP exam. If you wrote total distance, that's great. If you wrote change in position, that's what I always write, and you'll get the points. So V of t as the change in position is also correct. Whichever way you want to write it is fine. If you remember, hey, it's telling me greater than 0, I'm going to add it, change it to total distance, great. If you don't remember that and you want to just put change in position anytime you have that, great. The one time you do need total distance is when it has absolute value, you need total distance. Whereas without absolute value, either one's okay. And position's actually kind of always right. So if you want to do that, that's great. Okay, now after you do the change in position, you need in. Displacement's okay also. Yeah, if you're in physics, displacement is the same thing as position. So that works as well. Kind of the calculus word that's used more commonly is position, whereas the physics word that's used more commonly is displacement, but those two mean the exact same. So integral v of t dt is pick one of those three, and then in units, right? This is what's going to change. So in this case, we go back up here, and we had miles per hour, but remember when we take the integral, it chops off the per hour. So in miles, and then we need the from. So from, and then this is, again, something that's going to change in our problem. Ours is from t equals 0 to 2.4 hours. So we need the units there also. So that's kind of like a little bit of a sentence starter for you on these. Obviously, this could change if it was the integral of a of t dt from 0 to 2.4. What would change would become, now instead of change in position, it would be change in velocity, because velocity is the integral. And then our units would be our velocity units, right? The units kind of match up with what you're saying it is, right? So in miles per hour, and then from 0 to 2.4 hours. They could have also done something like this. This one's even harder. So if they did this, what we notice extra is this 1 over 2.4. So if we got that guy, that is average value. And we want to think, okay, what's inside is a of t. So it's the average acceleration. And then our units would be our units for acceleration. So in miles per hour squared. They don't chop off, they stay, whatever that is, from 0 to 2.4 hours. If instead of a of t, we had v of t dt with the same integral, then it would be the average velocity in just miles per hour, right? Because those units will match up. So I know we had trouble with these and a lot of us were getting these wrong. So that's why I just kind of wanted to go over some different possibilities. I think once you get the hang of them, they're not too bad. It's just that there's a lot to remember. So anyways, this right here, that would be full credit. So now let's make sure we're reading everything, right? So first they asked us to interpret the meaning using units. We did that. Okay, next, approximate the integral using a midpoint Riemann sum with 3 subintervals. So first, we're going to kind of look at that 3 subintervals. So 3 subintervals means we're going to go 1, 2, 3, every other one. And the width here is 0.8, the width here is 0.8, the width here is 0.8. And our middles are 11.8 is the middle, 17.2 is the middle, and 16.8 is the middle. Some AP exams will actually factor out the 0.8 because it's the same in all of them. So you'll see something like, 0.8 and then a parentheses and then all 3 of them. I like to do them just one by one, but if you factored it out, that's great also. Right, so each one of those where 0.8 is the width times the middle. And like I said, if you factored it out like 0.8 times 11.8 plus 17.2 plus 16.8, that's okay also. But remember, you can only ever factor it out if those widths are all the same, which usually only happens on midpoints. Usually on left, right, trapezoid, the widths are changing. So that's why I don't usually ever factor it. I usually just kind of go one by one. So we do that and we get 36.64, and then we want to report the units, right? And if we go back up here, if we forgot about our units, we already wrote what they should be in, miles. Or we can think, hey, we were taking an integral. When we take the integral, it chops off our units, so it's in miles, right? Because we started with miles per hour. Okay, C says for 0 to 2.4, Ruth's velocity can be modeled by the function given by g of t equals 24t plus 5 sine of t of 6t all over t plus 0.7. And according to this model, what was Ruth's average velocity during that time? So average velocity is 1 over b minus a integral from a to b of f of x dx. And so if we're doing average velocity, then it's going to be 1 over, our interval here is 2.4 minus 0, integral from 0 to 2.4 of the velocity dt. Now, I've seen this question asked where they say using the table, and so then this would have been 36.64, but they didn't say using the table. They said according to the model, which the model they just gave you was this new g of t. So what you do need to write down, you can't just write v of t. Okay, you can change this to g of t and write g of t because now you're showing them that, yes, I know what the model is. Or you could write out the whole integral. I mean, yeah, like 24t plus 5 sine of t, you could write out the whole equation. But either way, we need to make sure we're doing that. And I am going to show this one on the calculator just quickly, just because so many of you guys I saw doing these in separate lines, where when you do these in separate lines, you can make mistakes and you waste a little bit of time. So we don't have to do it in one line, but it's good practice. Now, another thing that I wanted to point out that's good practice is anytime we're doing two things together, just putting in that multiplying sign. We saw the other day that when we had like xy, that's different than x times y. Those are two different variables. Whereas when you write xy, the calculator doesn't realize it's x times y. It thinks it's some new variable like z. So we do need to make sure actually we pick the integral that has the endpoints. So from 0 to 2.4, and then we had 24t plus 5 sine of 6t all over t plus 0.7. If you want to change those all to x's, you can change them all to x's. And we get 14.0643. And our units on this one, we need to be careful. We did do an integral, so normally that would chop off miles per hour back to miles. But because we're doing average value, this actually adds it back on, so it remains miles per hour. And two other hints that those are your units are that they asked us for average velocity. Well, the units of velocity are miles per hour. And then that word average, we're doing average value. The units for average value always stay the same. All right, D, according to this model, is Ruth's speed increasing or decreasing? So we need to be careful with speed increasing and decreasing, right? Most of the time we see increasing and decreasing, like 99% of the time or 95% of the time, right? We make our V prime and we figure out like the positive and the negative stuff. With speed, we do not do that. With speeding up, speed slowing down is the same thing as speed increasing or decreasing. This is where we need to check the signs for V of t and A of t. So anytime we see speed increasing, speed decreasing, slowing down, speeding up, our game plan is just to go ahead and check those two signs. So, and again, according to the model given in part C, so they want us to use this equation. This was a 1.3, by the way. So on D, really all we have to write is we write V of 1.3 equals, and then on our calculator, we can just, since we already typed this in, we can come up here, hold down Shift on your calculator, and then right click it. There's no right click for you guys. Control C, and then come down here and Control V. And then this is that equation. We're going to do Control Enter at time equals 1.3. And we get 18.0963. And really all we're caring about is the sign, but we do want to show them that we know that we did type it in. So 18.0693, we're going to write greater than 0. Now we're going to do the derivative because we want the acceleration. And this is again where I've seen people do it in 2 lines. If you're scared, you can do it in 2 lines. I think I still have that copied, so I can go ahead and paste it again. And then outside of the parentheses, we need to put Control equal Enter at time equals 1.3. I want to show something because I did see a couple people who did it inside the parentheses. When you do it inside the parentheses, you always get 0. And the reason you pretty much always get 0 is what it's doing is it's doing PEMDAS. So PEMDAS says to do what's inside the parentheses first. When you do what's inside the parentheses, we actually got 18.09. So what this is essentially asking you, when we write it this way, is we were asking the calculator to take the derivative of 18.0693, which is a constant, which is going to give us 0. So that's why it's really, really important not to do that and to always make the T outside of the parentheses. Now, if you're worried about that and you wanted to do it in 2 lines, you do that, you get that big nasty thing, and then hit Control Enter, bring that down, and now plug in at time equals 1.3, and we'll get our same answer. To me, that's just weird, but I would prefer to just kind of do it all in one line. So that's my preference, but just showing you different ways you can do it and one way that we really cannot do it. So we do that. We got 3.7611 or 12 if we round it. So A of 1.3 was 3.7612, which is also greater than 0. It's really important that we show that greater than 0. So now we can say, therefore, Ruth's speed is increasing. It's important to say at time equals 1.3 hours. That's kind of very important, that when is it increasing? And I'm just going to say because V of 1.3 and A of 1.3 had the same sign. And we showed that with our work. Okay. So next question, we have a store is having a 12-hour sale. The total number of shoppers that have entered the store after the sale begins with S of T. So we see entering the store like rate in. Now, is this a rate or is this the amount? We want to make sure we know. So this is interesting. This is kind of a rate in, rate out question. It's good to try to identify like what our question types are to help us to like really know what formulas to use and to recognize the patterns that we've seen in all these practice questions. But the AP test is constantly trying to just do different little things, change the problem slightly to make sure that you really understand the concept. And honestly, even more so this year, they're going to do that. I don't know if you guys saw, there was a tweet by one of like the heads of the AP program that said our exam is going to be open notes. So if it's open notes, 2 things that we need to make sure is little things like speed increasing, speed decreasing. If you have to look that up, it's not going to kill you. But if you have to look up things that you should know, you're going to be wasting your time, right? It's still only 45 minutes. So we still want to have mostly everything memorized, because now they're going to try to really change the questions so that you can't Google them, and so that they're making sure you really understand the concept. So that's what they did here, is that S of T is the total number of shoppers. So it's kind of already that amount, right? When we think like the formula we've been practicing is like the amount at some time T equals the amount at 0 plus the integral from 0 to time of like the rate in minus the integral from 0 to time of the rate out. If that's like our big overarching formula, and the concept is kind of like the integral of the rate gives us the change in the amount, right? That's like the general concept. Well, the total number of shoppers who have entered the store is given by S of T. They already gave us that amount. At time 0, when the sale begins, there are no shoppers in the store. So S of 0 equals 0, which they didn't really have to tell you, because you probably could have just plugged it in here. But I think they're telling us that because, the amount entering is a change. So A says, at what rate are shoppers entering the store at time 3? Now, this is where we really need to go back and just make sure, right? On most questions, on a lot of questions, like S of t would have already been the rate on other questions. So we would have just plug in S of 3. That's very common. But on this question, S of t was not the rate. S of t was already the amount. So for this question, if we have the amount and we want to get to the rate, then we need S prime of 3. We need its derivative. And because this is a calculator question, that's all you have to write down. And then on your calculator, you're going to come back here, and we're going to do that same process, d dt of 0.5 t to the 4th. Make sure you hit the right arrow, minus 16 t cubed plus 144 t squared. And then outside the parentheses, control equals at time 3. We get 486. And all you needed to write was S prime of 3 equals 486. Now, it does not say indicate units. So that's correct right there. We don't need to do anything else. It's just 486. Now, if we wanted to indicate units, S of t was in the total number of shoppers. So the units of S of t was shoppers. And they're saying t is in hours. So if we take a derivative, we're going to add on that per time. So this would become shoppers per hour, or you could use the slash, like shoppers / hour. But if you didn't have the units there, it's okay. They didn't ask for them. We go back and we make sure we read it. At what rate are shoppers entering the store? At time 3, they don't ask for it. We're okay. All right, B asks us, find the value of 1/3. So as soon as we see this 1/3, we're immediately thinking that that's going to be that average value. And then using correct units, explain the meaning, right? So we know that we're going to be doing average value. There are actually 2 strategies on this one. The way that I did it, which I think is a little bit easier, is that, so the integral of 1/3 integral from 6 to 9 of S prime of t dt, right, becomes 1/3. The integral of S prime becomes S of t from 6 to 9. So that becomes 1/3 times S of 9 minus S of 6, right? Which is that FTC. You guys could have actually just jumped straight here if you would have like kind of applied FTC. You could have also had 1/3 S of 9 minus 1/3 S of 6, right? Distributing it, just making sure like the 1/3 goes in both. So that's one possible way to do this question. On your calculator then, you would just type in one-third, and then for here, actually we can come up here. Right, I think we had it. Oh no, we never did that. Okay. So we can go ahead and copy this. So Control C, Control V, at, right, we're plugging in 9. And I'm actually going to just grab this whole thing and say we want to do that whole thing again. So minus Control V, but now, oh wait, I don't think I got it. So we're going to grab that whole thing control C minus control V, there we go, and at times 6. So we get 301.5. So we do that, we get 301.5, and our units are going to remain shoppers per hour because of that average value. And I'll talk about that in a minute. Now, that's one way to do this. I did see a lot of people solve it a different way, and honestly, I think more people in our class would probably do it this way. So it's that for S prime, couldn't we just essentially go into our calculator and take the derivative without any time, right? Just get the general derivative. And when we do that, we get 2t cubed minus 48t squared plus 288t dt, right? That was the derivative. If you ever see these periods on your calculator, those periods are just telling you that it is a whole number, like it's 2.0 forever. It's one of the settings, you can change it if you don't like it there. So then I would do 1/3 integral from 6 to 9 of control C, control V, dt. We don't need any ats, and we get the same 301.5. So either way, we get 301.5. Now, then, so 301.5, that would have been 1 point. Okay, the second point here is for this using correct units, explain the meaning. So remember, kind of like our sentence starter, we had 1/3 integral from 6 to 9 of S prime of t dt is, now we want to think, what is it? Well, we have the 1/3, so we know it's the average of something. And it's the average of whatever is in here. So S prime would be the average rate that shoppers are entering. And we can even use A to kind of word it the way they did it. So it's the rate shoppers are entering. So it's the average rate shoppers are entering the store. And we always need in our units. So in, now, the rate shoppers are entering needs a per time. So it's in shoppers per hour. And then from t equals 6 to 9 hours. Or you could say between 6 and 9 hours. So that's just kind of going back to that same, if you use that as like a sentence starter for all of them, you should basically have everything that you need. Then it's just a matter of matching up what we have. Okay, see the rate at which shoppers leave the store. So now we're having leaving the store. And the hard issue with this is they're giving us a rate. And sometimes they do that. So what's happening here is that S of t is an amount, but now L of t is a rate. So those are two different things. They're slightly different. So the rate at which shoppers leave the store measured in shoppers per hour is modeled by the function L of t equals negative 80 plus 4,400 over t squared minus 14t. According to this model, how many shoppers are in the store at the end of time 12? So this is kind of interesting, but you can set this up a few different ways. Remember, when we want the total amount, like, so the amount at time 12 is always equal to the amount at 0 plus the integral from 0 to 12 of the rate in minus the integral from 0 to 12 of the rate out dt. That's our general overarching formula. So what is going to be the same no matter what is that a of 0 was 0. And I'm going to leave this part blank for right now. And the integral from 0 to 12 is just going to be L of t. That is the same no matter what. Now, for the rate in, we kind of have two different choices because remember, S of t was not the rate in, S of t was the amount. Well, if we apply FTC, we could kind of change this whole thing by FTC to S of 12 minus S of 0. And S of 0 is also 0 if you plug it in or just reading the question. It says at the beginning there are 0 people. So this gives us a formula of the amount of time 12 is equal to S of 12 minus the integral from 0 to 12 of L of t dt. And this is what they have on their answer key. And I really want to make sure we talk about this because if anyone's trying to do this on their own later, this is not from our normal formula where we start off at 0. We didn't, S of 12 is not our starting point, right? S of 12 came from the rate in. So in your calculator, you would just go back and you would get S of 12, which we already typed in. So Control C, Control V. There we go. At time 12, and you get 3456. And minus the integral. And this is this new one. So from 0 to 12 of negative 80 plus Control divide will give us that 4,400 over t squared minus 14t plus 55 dt. If we get something weird like this, just Control Enter or double check that we wrote this correctly. Negative 80 plus 4,400 t plus 55. Okay, Control Enter. There we go. Okay, there we go. I don't think I was hitting Control. So anytime you get, I typed that in a bunch of times, or it's just not working on me. There we go. Okay. So anytime we get something nasty, Control Enter will get it to us as a decimal. So this was 3260.2983. Go ahead and subtract these. And we'll get our answer of 195.7017. And it says give your answer. So when we go back and reread this, it says give your answer to the nearest whole number. So to the nearest whole number, that's approximately 196 shoppers. Now, I want to go back here and just look at this because there is a second way we could have done this. So if we kind of think about this guy here. That didn't work out. So that a of 12 equals a of 0 plus the integral from 0 to 12 of s of t dt. And s prime dt minus the integral from 0 to 12 of L of t dt. And the reason I'm writing it that way is this we had written as rate in, right? So we had put rate in here. Well, what is the actual rate in? The rate in is not S, right? S was the amount. So S prime would be the rate in. So we could have changed this to S prime of t dt. And without boring you guys and typing it all in, essentially this is 0. This is still 3260.2983. Right? We already did that on our calculator. We don't need to retype it. And what we would do is back up here, we had taken the derivative. We had already taken the derivative. And so this here is S prime. So if we copy this, really all we need to do new would be to take the integral from 0 to 12 of what we copied, dt, and you actually get that same 3456 that we had. So a lot of times with FTC, not always, but a lot of times with FTC, right, S of 12 minus S of 0, you could do it the other way of actually taking the derivative. Okay, and then lastly, part D says, using the given models, find the time where the number of shoppers in the store is the greatest, and we have an interval. So this is absolute max. Anytime we want the greatest or the least or any words like that, and we have some interval, we know we're doing absolute. So we know that at some point we're going to be making a table, right? We want the number of shoppers, so it's going to be like T, and I'm just going to write number of shoppers. If you want to write amount like A of T, you could. So we always on this one, and it's always worth 1 point, which is really nice, is that basically our rate in minus our rate out, or our derivative, is equal to 0. Now this question's a little bit harder because, right, we said that S was our amount in, right, where it makes S prime the rate in. So for rate in, we're going to put S prime of T. But for rate out, it was just L of T. So the reason this is kind of weird for some people is that S prime has a derivative and L does not have a derivative. So anyways, back here on our calculator, we just go to solve, right? Menu. I want to show this today because we haven't done this in a while, and I'm pretty sure it's going to be happening on the AP exam. Now, we already took the derivative, so that's what I've copied. That 2t cubed is the derivative. And then minus, now let's make sure that we put this in parentheses for L of t. So L of t was this big thing here, but we need to make sure we're using parentheses because we're subtracting the whole thing. If you don't have those extra parentheses there, you're going to get this question wrong. So we have that big parentheses and then equal to 0, comma t. And outside of our parentheses, we're going to put the at 0 less than time. Oops. Less than 12. And we get 5.545. 1 if we round it. And so in our table, we have 0, 5.541, and 12. They told us in the question that at time 0, we had 0 shoppers. That was given. For time 12, that's actually what we solved up here. And this is usually what happens is usually in these questions, in these greatest or least questions, not always, but like I would say 9 times out of 10, this first one was given. And then your other endpoint was from, part C or part B or whatever the previous, you had just solved for it. So now all we need to do is solve for the middle one. And we're going to do this the exact same way. You don't even have to write anything out, okay? Like the AP readers will kind of know that you've already been doing this. But if you want to write it out, essentially it would become the amount at 5.541 is equal to the amount at 0 plus the integral from 0 to 5.541 of S prime of t, right, the rate in, minus the integral from 0 to 5.541 of the rate out, which was L of t dt. This is 0, right? So in our calculator, it's essentially just redoing what we did up here. So this is our rate in. And instead of doing, you want to, instead of going to 2 decimals, 3 decimals, you want to go to as many as you can. You can even copy paste it and it'll get all of them. And then I'm going to just do this in one line. So I'm going to put minus, and I'm going to come up here and I'm going to grab this integral, but we're going to change the 12 to a same thing, 5.545066, and we get 1361.833. And I didn't do it totally exact, so actually my answer is slightly different than the AP answer. So if you really, really want to make sure that we're doing this right, you would want to just copy paste that whole thing, because the more you round it, the more you actually get it different. And when we're looking at, like, the AP graders are grading your fourth variable, or your fourth decimal, you want to be pretty careful with that. So yeah, I don't know exactly what I did. Okay, here we go. So you're going to copy this, and then up here in this endpoint, you're going to paste it. And it won't seem like it's too much of a difference, but I just want to show you guys this. Is that, remember, they're grading us to like the fourth decimal, right? 8328, whereas this is 8331. 28's a little different than 31. So we just want to be careful. Now, you're probably going to get the right answer either way, as long as you rounded this. If you rounded this 2 up to a 3, you would get the right answer. But if we just left it at a 2, we would get the wrong answer. So we just want to be careful on that. So anyways, they asked for when is it the greatest. So the real answer, the when, is at the 5.541. But I showed you guys this is, I like to just always do this kind of as a sentence where we use both. So kind of writing the 1361.833 shoppers is the greatest amount, or whatever we write, at time equals 5.541 hours. That way we have both the time with units and we have the amount with units, so we can't get that wrong. Okay. So what I want to do is look at this guy over here very quickly for like 2-3 minutes. We're not actually going to solve it. So this one, I don't remember if I gave it to you guys on an exam. I think one of the previous questions we actually did have on an exam. I think the first one we had on an exam. But this one here, grass clippings are placed in a bin. This is going to be the extra credit. So the amount of grass clippings remaining in the bin is modeled by A of t equals 6.687 times 0.931 to the t power. So this is a calculator question. You're definitely going to want your calculator. And they're saying that A of t is measured in pounds and t is measured in days. So kind of a good key there is that because A of t is measured in pounds, right? This is that same thing where this is the amount, not the rate. So it's very similar to the one we just did. Now it says find the average rate of change. If we're doing average rate of change, that's either the average value 1 over b minus a, or it's the y2 minus y1 over x2 minus x1. And since we're finding the rate of change of A of t, we want the rate of A, not the value of A. Since it's rate of change of A, then we're going to do the whole f of b minus f of A. Right? If they had said average value, then we would have done the other formula. Find A prime of 15. You have a calculator, you're just going to use it. C says find the time for which the grass clippings in the bin is equal to the average amount of clippings. So we want to think, okay, find the time for which the amount of grass clippings is equal. So we're going to need two things on each side, right? The amount of grass clippings, that's just A of t, and is equal to the average amount of grass clippings, not the average rate, but the average amount. So this is where we, like, this question was a question where it's really, really, a lot of people got it wrong because they just weren't careful with the wordings, right? The average amount would be the whole 1 over b minus a integral from a to b of A of t dt. And then for time greater than 30, the linear approximation, when we see linear approximation, that's tangent line, x1, y1, and m, is a better model. So using L of t to predict, L of t is that linear approximation, predict the time at which there will be 0.5 pounds of grass. Pounds would go in for your y1, or not for your y1, for your y after you get this equation. So you're going to have to set up an x1, y1, and m. And once you do that, then you would plug in 0.5. So this is a little bit of a different question, but those are just some hints for you guys if you're going to try the bonus. I will post the answers for the bonus, but it's not so much like, can you do it on your own? It's just an extra question that you can try. This second part of the bonus technically is not going to be on the AP exam. So don't stress on it too much. But I still do want you guys to do it. I'm being a little bit mean. If you're going to get the extra credit, you're going to do both of them. Because it's good practice to practice AP style questions, even if it's not going to be one that's tested. We just can use our notes a little bit more. We don't need to stress about memorizing it so much. But especially if you're going to move on to Calc 2 next year, when you go to college, this is going to be tested. So it's good to still get that practice in. So I'm going to post this. This will be extra credit. For everyone here, before you guys leave, I need to get a screenshot of who's here. So for you guys, on your assignment, just mark it as turned in. So there are going to be 2 assignments today. Number 1 is going to be basically worksheet 110. You guys just mark this as turned in. You get full credit because you were here. Number 2 is going to be the extra credit, which is going to be worksheet 111. It's up to you if you want to do it. And then I'm just going to kind of put as optional. I'm going to put, and I'll put it as an assignment, but I'll write the word optional on it, which is going to be the AP video. So here's kind of what I'll do in the grade book is in our grade book on Aries, which I need to start importing some of this stuff over. If you do it, then you'll get a 5 out of 5. If you don't do it, then you'll get an NA, which kind of doesn't help you and it doesn't hurt you. So it's just optional, right? If you do it, you're going to get points for it and it'll count. If you don't do it, then it won't affect you at all. It's kind of like I never assigned it. Guys, sound good? All right. So thank you guys, and I will talk to you guys tomorrow.